Hello everyone, welcome to this video on the circles concept in the geometry. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GT Cube Get to the Top. If you are watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of the course and also get to practice a lot of questions on these concepts that would give you a good practice and also help you understand these concepts better. So let's get started. So there are some basic terms that you need to really understand well before we get into some formulas for the circle. First, most important thing is the center, right? So center of the circle. Then the radius is the line joining the center of circle to any point on the circle, right? Let's say it's a point D or F or E. This is radius, this is radius, this is radius. OC is also radius. If I join to A also it's radius and to B also it's radius, right? So radius is a line, the distance between the center at any point on the circle, right? That's the radius, denoted by the R. Diameter is basically twice the radius, right? CD is the diameter, for example. A line that's joining 2 points on a circle which is passing through center is called the diameter. Chord is basically a line joining 2 points on circle, line joining any 2 points on a circle, right? If I join point A and point B, this is a chord. AB is a chord, right? Something like EF is also a chord, CD is also a chord. Important point you need to understand is diameter is the longest chord in a circle, because any other I can draw joining any 2 points would not be as long as the diameter. So a chord which passes through center is automatically diameter, and that's the longest chord you can draw in a circle. Arc, major and the minor arc, right? So let's say AB is a chord, I'm talking about this line, right? What about the arc? AB arc is basically this one, and I'm talking about this length, right? This is called the minor arc. The major arc is this remaining circle, right? Circle, I need to join the 2 points on the circle AB. So this is the minor arc, and automatically the other is the major arc. And this entire length is called the major arc AB. So that's why this is called the major arc. So that's why generally if I write it AB as the arc, we generally define the minor generally, but to be very clear they have to mention if it's a minor arc AB or the major arc AB, right? They have to give some qualifier like this for us to understand which arc are they talking about. Then the sector is basically, let's say if I have O, let me complete for AB only. Okay, let me do for EF only, right? So what is the sector for us? Or maybe let me do it for this first, right? So AB is this 2 points on the circle, and I said this is the arc, and this entire area is called the sector, right? So I call it sector, let's say AOB. If I say sector AOB, I'm talking about this entire shaded zone, right? A, O and B, this entire area is called the sector. Then there's something called segment. Segment is basically, if I'm talking about A and B, this is the arc, minor arc, and AOB is this is entire sector. So segment is this. If I join AB through a line, right? So AOB is a triangle, you can see here. In the entire sector AOB, it's basically this triangle plus this part, right? So this part is called segment. Leaving the triangle, the other part, basically this, all of this is called all the blue thing I'm shading now is called the segment. Segment, if I say AB, I'm talking about this basically, right? Then area of, obviously this entire area of the circle, that's what we're talking about. The area of a circle is pi r square, pi into radius square. Circumference is 2 pi r. Circumference is nothing but the perimeter, right? If I actually use a rope or a thread to measure across this entire circle, I wrap it around the entire circle, and then I pull it to make a straight line and then put it against the scale or any measuring tape, I'll get the perimeter, which is equal to 2 pi r. 2 into pi into the radius. Pi is generally 22 by 7. When you calculate r, you can also approximate it to 3.14. If the options are, the question is giving answers in pi itself, we leave it here. If you have to calculate further, you have to use one of these two to solve the question. Tangent is nothing but, if I have a point outside the circle, if I draw a big line, there are three possibilities. Let's say it's a point P. If I draw a line like this, it would not touch the circle. It will cut the circle at 2 points. Let's say there's a line like this. So let's say it cuts at x and y. Or it cuts the circle at exactly 1 point. That's the tangent. So that's basically around this point, let's say some point T. So that's the tangent. And what is the another thing that you need to know? From center to the tangent, if I draw, that will be 90 degrees. It's a perpendicular line. That's another thing you need to understand. That's it. A tangent is basically a line drawn to the point on a circle from an external point. Right? It goes through like this. And if I join the point of intersection, that is T, and the center for the tangent line, it will be perpendicular to the tangent. That's the thing that would be helpful for you to solve. So basically, this will be a Pythagoras, right angle triangle, P, T and O. If I join, right, I can make a right angle triangle. This is the radius, and I can solve the question based on the given clues. So that will be a useful property to remember if the question is framed on a tangent. So arc length and sector area, we have just briefly discussed about what is arc. If I am talking about EF is the arc, minor arc, what is that length? If we need to know this length, right? How do I know that length? So one thing we need to know is this angle theta, like how much is this angle? See, I know this entire arc, if I take, let's assume E, and then I draw an entire circle and come back to E, this is also an arc in a way. It's a big arc which is basically the entire circle. What is that called? Circumference. For the circumference, what would be the angle that needs to be covered at the point O? Starts at this, cover entire and come back to this point, which is 360 degrees. Right, for the entire circumference is 360 degrees. Now, if I am asking you what is the arc length for a theta, right, this is what I need to find, right? So obviously, cross multiply when I have a proportionality like this, circumference into theta is equals to arc length into 360 degrees, right? I'm just cross multiplying this, and 360 goes this side. So basically the arc length would come out to be theta by 360 into the circumference. What is circumference? It is 2 pi r. So it will be theta by 360 into 2 pi r. Very similar to sector area. This is what I need to find out. I have to find out that I know entire circle area would be 360 degrees, like how I found out circumference is for entire 360 degrees. For the required sector area, it is covering theta degrees. I cross multiply, I'll get this to be theta by 360 into the area of the circle, which is pi r square. The formula is theta by 360 into pi r square. That will give me the area made by this theta degrees for this entire sector. Perimeter of sector OF is basically I have to add the arc length EF, the minor arc, plus OE and OF. That's basically adding these two. And what are these two? Basically the radius, right? From the center to the point on a circle. So I just basically plus r. This is theta by 360 into 2 pi r. This is what we've talked right here. Arc length I can find out and then add the radius twice for OE and OF, and we are done with the perimeter. So there is one useful property related to the chord and the circle center, which is used a lot in solving a lot of questions related to the chords in a circle. So the property is this: the shortest line drawn from center to the chord is the perpendicular bisector. So from the center, let's say O is the center, I am drawing a line to the chord, right? If I know it's a perpendicular line, automatically I also know that OC cuts AB into two equal parts. That's why this is called the perpendicular bisector. It is perpendicular and bisects the chord into two equal parts. The shortest line from a point to a line, right? Basically from a point, if I draw a line and that has to be the shortest line, it is always the perpendicular line. Any other line I draw to the line let's say AB from the point O, it will not be shorter than this perpendicular line. That's why we are calling it the shortest line drawn from the center. But anyways, all you need to understand is this OC is the shortest line, right, from center to the chord. Or sometimes you might say, what is the distance, right, of center from chord, or what is the distance of the chord from center? Basically all talking about OC. Then CB is the half chord length. If I know CB, I can just simply multiply into 2 to get the chord length. And OB is the radius, right? So OCB is a right angle triangle, and I can use Pythagoras theorem. OB square is equals to OC square plus BC square. Simple. So radius square is OC square plus half the chord square, that's BC square. So based on what I know, is it the radius or the distance between the center and the chord, or the chord length, so that I can do half the chord length to get BC. I need to know 2 out of these 3 to figure out the third one. So that's how the questions would be generally be framed. If I know that there's a line that is joining the center and the chord, and it is splitting the chord into 2 equal parts, it has to be the perpendicular line. If I know it's a perpendicular line drawn from the center to the chord, it has to cut the chord into 2 equal parts. One thing I know automatically, the other has to be true. That's a useful property that you can apply to solve the questions. Other useful property in circle related to the angles is the theta 2 theta relationship. So listen to this carefully. I have 2 points A and B on the circle. Then I have third point C on the major arc, right? On the major arc of the circle. If ACB is making theta, right, that is angle made by ACB, if that is theta, then AOB, that is these 2 points with the center, make twice the angle, that is 2 theta, right? So 2 points, the third point on the major arc, and I make angle theta, then these 2 points AB with the center O makes an angle double that. So if this is theta, this is 2 theta. Let me take the other point D, right? If I join A, D and B, this will also be theta, because AB with the center with the O makes 2 theta, then obviously ADB has to be theta. I take, let's say, another point here. This also has to be theta. Any point, same, theta. There is no way that we'll have something else as the answer. All of them would be theta, 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 and that's why this is 2 theta. When it comes to a point on the interior minor arc, right, what should you understand is this. It's, if I don't know whatever this is, let's say this is 2 theta, right? What we have just figured out, theta, let's assume that's still valid, okay? Let's say I have a point here, AE, then automatically AEB is making theta, then this is 2 theta, all fine. Then what is this angle making? This is not theta. What you should do is this, whatever this angle is, let's say this is y, then this is y by 2, right? Whatever this angle is, half of it is what this angle is. If this is 2 theta, what is y? Entire should be 360 around this point, so it should be 360 minus 2 theta. So this will be half of y, so that is half into 360 minus 2 theta, that will come out to be 180 minus theta. So this point will be 180 minus theta. If this is 2 theta, this is 180 minus theta, and this is theta, and this is 360 minus 2 theta. That's the relation. So one simple point you can remember is this: 2 points A and B on the circle, a third point on the major arc makes theta, then automatically any point on the minor arc will make 180 minus theta with these 2 points. So if this is theta, this has to be 180 minus theta, and this is 2 theta. These are the 2 things that you need to know, to solve the questions based on the angles in a circle, using the theta to theta relationship. So let's solve the problems to understand these formulas better. So the diameter, from the following figure, find the given values that needs to be found. Radius is given as 9 centimeters and this angle is 120 EOF. So let's start. What is the diameter? Twice the radius, so that is 2 into 9 is 18, simple. What is the area of the circle? Pi r square. Pi into r is 9 square, that's 81 pi is the answer for the area of square circle. Circumference of the circle is 2 pi r is the formula, so that's 2 into pi is, obviously I'll keep it pi only, 2 into pi into 9, that is 18 pi. Length of the minor arc EF, so I need to find this arc, right? If you remember, as I said, to find out this, I need to know the angle it is making at the center, so that is, for D it should be theta by 360 into 2 pi into r, right? This is circumference. So to find out EF length, I need to do theta by 360 into 2 pi r. So this is 1/3, 123 is 360, 3 1s are 3 3s are, this is 6 pi. So length of minor arc is EF is 6 pi. Area of the sector OFE. OFE sector area is basically, I need to find this entire area, and what is the formula that I need to be using? Theta by 360 into pi r square. So that is 120 by 360 into pi into 9 square is 81. So that's 121s are 123s are. So 81 pi by 3, 3 1s are 327, sorry. 27 pi is the answer for this sector OFE. And finally, the perimeter of the sector OFE is OFE. I need to add this arc length EF, and then I also need to do OE plus OF is basically the radius twice. So right, plus R is the perimeter of the sector OFE. The arc length is 6 pi plus the radius is 9 plus 9. So that's basically 18 plus 6 pi is the perimeter. That's how you solve it. Now, the second question, the radius of a circle is 20 centimeters and length of one of its chords AB is 32 centimeters. Find the distance of the chord from the center. As I said, that's the simple property that we discussed. This is the chord length AB, right? The radius of the circle is 20. Chord length AB is given as 32. What is the distance of the chord from the center, right? From the center, so I need to find out this distance x. As I said, the line joining the center and the chord will be perpendicular bisector, cuts into 2 equal parts. So what will be the arc length is 32, so AD is 16 and this is 16. What about OB? That's the radius that's given to be 20. So finally it will turn out to be a right angle triangle. This is the radius 20. This is half the chord length 16 and this is x that I need to find, the distance between the center and the chord. X square plus 16 square is equals to 20 square. That's x square plus 256 is equals to 400. This goes this side, 400 minus 256 is 144, x is 12, right? So the answer is, the distance between of the chord from the center is 12, right? All we did is just use the Pythagoras theorem for the right angle triangle. You just need to, fit in the right values based on the given question, right? There is like a very simple application of this, the perpendicular bisector property of the chord. In this question, we need to find the value of x in the given circle with the center O. So this one we need to use the theta 2 theta relationship. So 2 points A and B, and this is the center O, right? If this is 40, automatically I know that this must be 40 as well, because if you remember this, A, B 2 points, I draw to any other point, third point could be any point on the major arc, they should make the same angles. If this is 40, this has to be 40. Right. Another property which we have not explicitly discussed in the video is this, that angle in a semicircle is always 90 degrees. That is, if I have points A and B and they are making, this is the diameter, then this has to be 90. Why? See, AOB, that's like 2 points on the circle with the center. What is the angle they are making? 180 degrees. If this is 2 theta, then any other point on the arc, they have to make 180 by 2, 90 degrees. That's why angle in a semicircle is 90 degrees is like a property that we get, but it is coming basically from the theta 2 theta thing. So why do we need to use this here? DOB is that diameter and DAB is the triangle inside the semicircle, right? So DB is the diameter. So I'm talking about D is a point, B is a point, and the third point is A on this arc DB. So angle DAB must be 90 degrees because DOB is 180 degrees. This is 2 theta, then this has to be 180 by 2, that's 90. So now finally it will turn out to be this. Triangle DAB, this is 90, this is 40, and this is the x that I need to find, right? X plus 90 plus 40 is 180, so x is 50. Right, 130, that's so basically 50. The answer is 50 degrees. That's it. That's how you find the value of x in the given circle with the center O. Right, all we did is to apply this theta 2 theta thing. So yeah, this could be a bit complicated in the beginning if you're not comfortable with this at this point of time. Try a couple of problems on this and then try to visualize this clearly and we'll get clarity on this. Right. Just focus on the points like this. Whenever you're trying to find the theta 2 theta, try to pick 2 points A and B. Then where is the third point I am worried about? That's point C on the major arc. If this is making 40, then what else can I do? I can understand that AOB will be 80, or I can understand AB and any point on the circle is, let's say, point D. This also should be 40. So that's how you should look for 2 points on the circle. See any point on the major arc I know, or maybe the angle made with the center is something I know. Then I can apply theta to solve the question. So thank you for watching this video. If you're watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store. Where you'll get to watch these videos as part of the course and also get to practice a lot of questions on these concepts. Also, like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of content that would help you in your preparation. All the updates and the notifications would be shared over there, so don't miss that. Finally, thank you for watching this video, and let's meet in the next video.